Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So to solve this, I'm going to first go ahead and subtract 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now, x to the power of 6 here, I'm going to rewrite as x to the power of 3 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2 here, I'm going to rewrite as x to the power of 3 to the power of 2. So I have this minus x to the power of 3 minus 2 is equal to 0. And now I'm going to let x to the power of 3 equal to the variable y. So now I have y squared minus y minus 2 is equal to 0. Now we have a simple quadratic equation here. So to solve this, I'm going to rewrite negative y here as negative 2y plus y. So now I'm going to factor by grouping. So if I factor out y from y squared minus 2y and factor out 1 from y minus 2, because 1 is the greatest common factor of y and negative 2. So first off, factor out y, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2 from here, I get y minus 2 times y plus 1 is equal to 0. So now this gives me two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, y is simply equal to 2, and for y plus 1 equals 0, y is equal to negative 1. Now, recall how we let x to the power of 3 equal to y. So if x to the power of 3 is equal to y, and we have two values of y, well, let's first start with y equals 2. So x to the power of 3 equals 2. I'm going to take the cube root on both sides. Cube root of x to the power of 3 is x, and so we have x is equal to cube root of 2. Now, for negative 1, I have x to the power of 3 is equal to negative 1. I'm going to take the cube root on both sides. Cube root of x to the power of 3 again is x, and the cube root of negative 1 is negative 1. So my two solutions for this are the cube root of 2 and negative 1. So now to check, I'm going to plug these two in. So first, the cube root of 2 . So the cube root of 2 to the power of 3, that's simply equal to negative 2. And the cube root of 2 to the power of 6 is 4, so I have 4 minus 2 equals 2, and 2 equals 2, so this is right. And negative 1, I have negative 1 to the power of 6, which is 1, minus negative 1 to the power of 3 is negative 1. 1 minus negative 1 is 2, so I have 2 equals 2, so both solutions are right. Alright, so in this problem, I have 9 to the power of x minus 3 to the power of x is equal to 12. So to solve this, I'm going to first start by rewriting 9 here as 3 squared. So now I have 3 squared to the power of x minus 3 to the power of x is equal to 12. Now I'm going to rewrite 3 to the power of 2 to the power of x as 3 to the power of x to the power of 2. Because if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. So now I'm going to let 3 to the power of x equal to the variable y. So now if I substitute in y in for 3 to the power of x, I get y squared minus y is equal to 12. Now I'm going to subtract 12 on both sides, so then these two cancel out, and I get y squared minus y minus 12 is equal to 0. So to factor this, we have to find out which two numbers multiply to get negative 12. So a times b is equal to negative 12, and they add to get negative 1. So a plus b is equal to negative 1. Well, negative 4 and 3 work out because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So now I have y squared minus 4y plus 3y minus 12 is equal to 0. Now if I factor out y from y squared minus 4y, I get y times y minus 4 plus the greatest common factor of 3 minus 12 is 3, so I get 3 times y minus 4 is equal to 0. Now I'm going to factor out y minus 4. So I get y minus 4 times y plus 3 is equal to 0. So this gives me two equations. I have y minus 4 is equal to 0, and I have y plus 3 is equal to 0. So for y minus 4 equals 0, I get y is equal to 4. And for y plus 3 equals 0, I get y is equal to negative 3. So remember how we let 3 to the power of x equal y. So now I have 3 to the power of x is equal to 4, and 3 to the power of x is equal to negative 3. Well, 3 to the power of x equals 4. To solve this, I'm going to take the log on both sides. So then I get x times log 3 is equal to log 4, meaning x is equal to log 4 over log 3. Now for 3 to the power of x equals negative 3, you can't take the power of a positive number and make it negative, so there's no solution for this, and my only solution is log 4 over log 3. Alright, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x here. So for my solution, first start with x to the power of x to the power of 6 is equal to 144. And now I'm going to take the power of 6 on both sides. So now I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, right? And a to the power of m times n, well, this is the same thing as a to the power of n times n, because when I'm multiplying two numbers, I can switch the places of them two. It's still the same value. So if a to the power of m to the power of n is equal to a to the power of m times n, and a to the power of m times n is equal to a to the power of n times m, this means that this is the same thing as a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 6 to the power of 6 is equal to 144 to the power of 6. So we can think of x to the power of 6 here as m and 6 as n. So if I switch the places of these two, I get x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. So now I'm going to let x to the power of 6 equal to the variable y. So now I have y to the power of y is equal to 144 to the power of 6. And 144, this is the same thing as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, as I already said before. So 12 to the power of 2 to the power of 6, that's going to equal 12 to the power of 2 times 6, which is 12 to the power of 12. And if I have something from a to the power of a is equal to b to the power of v, this means that a is equal to b. So in this case, y is equal to 12. So now remember how we let x to the power of 6 equal y. So this means that x to the power of 6 is equal to 12. So if I take the 6th root on both sides, 6th root of x to the power of 6 is x. So I get x is equal to 6th root of 12. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have a to the power of a is equal to 2 to the power of 8. Now 8, this is the same thing as 4 times 2, right? So now I'm going to write this as a to the power of a is equal to 2 to the power of 4 times 2. And now, if we have something in the form a to the power of m times n, we could write this as a to the power of m to the power of n. Or we could also write this as a to the power of n to the power of m. It doesn't matter the order because they're both being multiplied, and multiplication order doesn't matter. So now I'm going to write this as a to the power of a is equal to 2 squared to the power of 4. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this would equal 2 to the power of 2 times 4. However, I am not going to do that. I'm simply going to solve what's in the parentheses. So 2 squared, and that is equal to 4. So now I have 4 to the power of 4 is equal to a to the power of a. Now, if we have something in the form x to the power of x is equal to y to the power of y, and this means that x is equal to y as long as x is greater than or equal to 1. So in this case, a is equal to 4.